resolve each force into its x and y components. That means that we are going to show x component of each force and y component of each force. We have three forces, F1, F2, and F3. I start with F1. F1 is equal to, so it has just one component because it's acting in x direction. So it's going to be 18I. I'm writing this kips in front of it. So 18,000 I or 18 kips I or 18 kips, I write kips in front of it. F2 is the second force and the angle 45 degree is given for this force. I have recorded a video, you can watch it. It shows how to deal with the angles or the forces that have angles or the forces that have this triangle on them. So the second force has an angle. It's going to be equal to 15 times cosine 45 because 45 is adjacent plus 15 times sine 45. Again, the opposite is in y direction and that's sine. This first one is I and the second one is j. Again, I'm writing this kips in front of it. And if you solve this, it's going to give us 15 times cosine 45 is equal to 10.6i, and cosine 45 is equal to sine 45. Therefore, it's going to be 10.6j as well. And I have not forgotten this kips because it's 15,000 or this in 10.6 thousand pretty much. This is F2. I wrote F2 also in Cartesian or in XY format. Now I'm writing F3, which for F3 this triangle is given and you have to pay attention to the direction of the force. You can see that it's acting in the positive x direction but negative y direction because positive y is upwards. This force is downwards. Therefore, it's going to be 13 times parallel with x is 4. Therefore, 4 times 4 over 5. This is our I. And like I said, it's negative y direction 13. Negative 13 times parallel with y is 3. Therefore, times 3 over 5 j. And I put this inside parentheses. Again, I have not forgotten this kips. I'm writing it in front of it. And if you solve this, it's going to give us 10.4 I and negative 7.8 j. Again, write this kips in front of it so that we know that it's in thousand. Now I have F1, F2, and F3 in each one and its components. So I have solved the first part of this problem. You see that it's so easy. You have to just write each force in x and y component. Now that I have this, I can calculate Fr, which is the resultant force, and it's equal F1 plus F2 plus F3. Because I have F1, F2, F3 in Cartesian format, by adding them to each other, I will calculate first, or I will determine first Fr in Cartesian, and from there I can calculate the magnitude of this force. So it's easy. Just first collect the I components of each force, or add each I components to each other, and then j components to each other. This is j components. So we are going to add first I components and then j components. So from first force we have F1, from second force 18, from second force or from F2 we have 10.6, and from the third force or from F3 we have 10.4, and this is I components of our force. And then we have to add j components. The first force or F1 does not have any j component, but F2 has, and it's 10.6, and F3 also has, that's negative 7.8. don't forget, these are places that you may make mistake. You may forget to put this negative and stuff like that. So I'm putting this inside the parentheses again to write kips in front of it. So add them to each other. 18 plus 10.6 plus 10.4, it's equal to 39. This is our I component of resultant force. And 10.4 minus 10.6 minus 7.8 is going to be equal to 2.8 J component of our FR, or resultant force. So we calculated the resultant force as well. Now the magnitude of the resultant force is equal to square root of square. So 39 square plus 2.8 square. My bad, this is positive. I forgot to put positive. So 39 square, 2.8 square. And if you solve this, you will get the resultant force magnitude, which is equal to 39.1 kips. So this is the magnitude of the resultant force. And to find the direction of it, you need to calculate this theta, which is equal to FRY divided to FRX. So tangent -1, FRY is 2.8 divided to FRX is 39, and if you solve it, you will get 4.1 degree, because this resultant force is something, this is X, this is Y, based on these magnitudes that we have, it's something like this. This is our FR, and this is the theta that we calculated.